Hello everyone, welcome back to Infinity Physics. In this lecture, we will discuss about inertia of direction. So what is inertia of direction? It is the natural tendency of a body to oppose any change provided in its direction. For example, you are moving in a car, that is here you are moving in a car in a straight line with a speed of 100 km per hour. Now what is happening? Suppose at some instant you take a sharp turn towards the left side. So in this situation you will feel a jerk. Your body will slip towards the right side. That is, your body will slip towards the right side because initially you are moving in a straight line, right? And now as you take the turn towards the left side, your body wants to remain in a same state of motion in the same direction. That is, your body don't want to change its direction of motion. So what body will do? The body will try to oppose that change, and that tendency of a body to oppose any change in its direction of motion is known as inertia of direction, right? So now let us try to look the another example. In a uniform circular motion in chapter number 8, it is given that any body moving in a circular path, the direction of the motion, the direction of its velocity can be found with the tangent. That is, if you draw a tangent at this position, then we will get the direction of its velocity or the direction of the motion. Similarly, I want to find the direction at this position, then I will draw a tangent at this position in this direction. So the tangent will give me the direction of the motion. So in a circular path, the direction of the motion of a body changes at each and every point. At this position, the direction is towards the left. At this position, the direction is towards the downside. At this position, direction is towards the right. So at all the point, the direction of the motion of a body changes. Now suppose at some instant at this position, the string breaks. In that condition, what will happen? The stone will move towards the left. Now it will not continue its circular motion because the force you are providing to move in a circular path is absent because the string breaks. So in this condition, what will happen? The stone will continue to move in its original direction. That is, at this position its direction of velocity, its direction of motion was towards the left. So now when at that position the string breaks, the stone will continue to move in its direction of motion, and that ability of a stone, that ability of a body to continue its direction of motion, to maintain its direction of motion, is known as inertia of direction. Now let us try to look some another point. Inertia of an object is measured by its mass. That is, if the object is heavier, that is, it has larger mass, then we can say its inertia is larger. For example, here you are having an object having mass of 10,000 kg. Now you are applying some amount of force to move that body. In that situation, the body will not move easily. Why? Because you are providing some external force, and that force is opposed by the body. Here the body is trying to oppose, and that opposing capacity, that tendency of a body is called inertia. So here the inertia of this body is larger. Now suppose if you try to move that body with the same force you are providing to the previous body, then this stone will move easily, this body will move easily. So we can say heavier the mass, right? Heavier the mass, larger is the inertia. That is another example. Inertia of a truck is very large compared to the car. Hence it is very difficult to move or stop the truck as compared to the car. Let us try to look some another examples. Which of the following has more inertia? Rubber ball and a stone of the same size. So you know that stone is heavier. So heavier the mass, larger is the inertia. So in this situation, the stone has greater mass and hence it has more inertia. Similarly, train and a bicycle. So bicycle is very light, so train has much larger inertia. Similarly, 5 rupee coin and a 1 rupee coin. So 5 rupee coin is thick, hence it has more mass, and as it has more mass, it has great inertia. Now in the next lecture we will look at the momentum. So have a nice day. Please subscribe and share with your friends and give your feedback in the comment section. Have a nice day.